This is the third video on the coordinate geometry of the straight line. It deals with the midpoint and distance between 2 points. Suppose we have 2 points, A and B, with coordinates x1, y1 and x2, y2, so they're general coordinates. And we want to find the midpoint between those two, M, such that AM is equal to MB. Well, first of all, on the x-axis, we know that the x-coordinate of A is x1, the x-coordinate of B, let's extend that there, the x-coordinate of B is x2, and we'll let the x-coordinate of M be xm. And that is what we want to find. Well, I'm going to draw this horizontal line here and this vertical line here. So there's a right angle, and we can see that if M is a midpoint of AB, then this point here, this point there, is the midpoint of this horizontal line. So this distance here would be x2 minus x1 over 2, because it is half of x, a half of that distance here. So xm would be this distance here plus this distance there, which is x1 plus x2 minus x1 over 2, which is 2x1 plus x2 minus x1 over 2, and 2x1 minus x1 is x1, so that's x1 plus x2 over 2. So that's the x-coordinate. The y-coordinate of M be this point, this value there, ym. If I draw that line there, by a similar argument, we'll find that ym, the y-coordinate of M, is y1 plus y2 over 2. So the midpoint between A and B, M, has coordinates x1 plus x2 over 2, y1 plus y2 over 2. The next thing we want to do is find the distance between the 2 points A and B. Now, if we complete a triangle like that, a right angle triangle, we can see that because this is the x coordinate of x1 and this is the x coordinate of x2, then the distance between them here is x2 minus x1, and the vertical distance between them here is going to be y2 minus y1. So by Pythagoras, we know that AB squared is equal to x2 minus x1 squared plus y2 minus y1 squared. So AB is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now here's a simple problem on this. We have the points A, 3, 4 and B, minus 1, 6 are the endpoints of the diameter of a circle. And we want to find the centre of the circle and we want to find the radius of the circle. So the centre of the circle O, of course, is the midpoint of a diameter. So the centre of the circle O will then have coordinates of 3 plus minus 1, x1 plus x2 over 2, and 4 plus 6 over 2, which is y1 plus y2 over 2. So 3 minus 1 is 2 over 2 is 1, and 4 and 6 is 10 over 2, which is 5. So the coordinates of the centre are 1, 5. Now the radius, part B, that's part A. So part B, the radius is the distance between O and A, from the centre to the circumference, or between O and B. It doesn't matter which we choose. So if we find OA, that would be the square root of x minus x, x1 minus x2, x2 minus x1 squared, whichever one you wish, 3 minus 1 squared. Of course, you could put 1 minus 3 squared. It's the same thing, because when you square it, you get the positive, plus y2 minus y1 squared, which would be 4 minus 5 squared. So that is equal to the square root of 2 squared plus minus 1 squared, which is 4 and 1. So that's the square root of 5. So the radius is the square root of 5. Now we have another problem here, which is find the equation of the perpendicular bisector of the chord AB, where A is 2, 5 and B is 3, 8. Now here we have the chord AB on a circle, and the perpendicular bisector of a chord is the line which is perpendicular to the chord like this, and it bisects it. In other words, it cuts it in half like that. So we wish to find the equation of that line. Well, in order to do that, we need two things. It's a line, so we need the gradient of the line and a point which it passes through. Now we can see that the line passes through this point here, which we'll call M, which is the midpoint of AB, and the gradient is at right angles to the gradient of the line is at right angles to AB. So we need to find the midpoint of AB, which we'll call M, which would be 2 plus 3, that's the x-coordinates, over 2, and 5 plus 8 over 2, which is 5 over 2, 13 over 2. Right, M is there. And the gradient of AB, MAB, is equal to the difference in the y-coordinates, that would be 8 minus 5, over the difference in the x-coordinates, 3 minus 2, which is 3 over 1, which is 3. So that's the gradient of AB. The gradient of the line, the perpendicular bisector, let's call that L. So ML would be minus a third, because it's perpendicular, and the two gradients, 3 and minus a third, you see multiply to give minus 1. So we now have the two things we need to find the equation of the line. Using y minus y1 is mx minus x1, where x1, y1 is the midpoint and m is the gradient. We'll have y minus 13 over 2 equals m, which is minus a third, x minus 5 over 2. So simplifying that, y minus 13 over 2 is minus a third x plus 5/6. If we multiply by 6, we'll have integer coefficients. 6y minus 39 equals minus 2x plus 5. So 6y plus 2x minus 44 equals 0, and that's the equation of the perpendicular bisector of the line. Or simplifying, of course, we can divide by 2. 3y plus x minus 22 equals 0. Now return to Study Smart, where you'll find an exercise where you can practice midpoints, distance between points, and together with equations of straight lines.